We start with what's the granddaddy of computers. I'm not sure how many of you recognize this computing device. Can you raise your hand so I know how many people recognize this? Quite a few of you. This is the ENIAC from 1946. It cost today's currency 6 million US dollars. How about the compute power? Well, it was called the giant brain. Danao, a giant brain at the time. It had 0.05 MIPS. MIPS, million instructions per second. That's one of the measures of how powerful the computer is. So it had 0.05 MIPS. How about today's computers? Well, today a typical laptop has more than 100 MIPS. So you have 2 million times more compute power in a mobile device, and it doesn't cost you $6 million, just a few hundred. Let's take a look at what happened after that. Desktop computers. So you see a historical, the Mac on the left, and today's state-of-the-art, all-in-one desktop computer. So even the desktop has come a long way. Not as giant a leap from ENIAC to the first desktop, but nevertheless very impressive. Next, the notebook computers. I'm showing in the middle my first ThinkPad when I joined Intel in 2000. And today you find all these ultra-thin, very interesting form factors, two-in-ones. So laptop has moved a long ways in a couple of decades. One click and you look at the revolution in the mobile devices. Tablets, smartphones, their volumes have surpassed the other computing devices. So we all carry this with us. What next? Wearable computers. Computers, as you can see, are getting disintegrated. It used to be ENIAC machine for a whole community of researchers, and then a desktop computer for every house. Then it became perhaps a couple of laptops or notebook computers for the household, the parents and the kids. And today we have a smartphone and a tablet for every one of us. In the future, the computer is getting disintegrated, and we'll have multiple of those devices per person. Maybe I'll have a wearable head-mounted display connected to the cloud, and it will help with personal computing. I'll have a smartwatch. That's a computer in its own rights. It will have sensors and computing power. A smart shirt will have sensors and some compute power in the shirt, which will connect to the cloud for more compute. So computing is going everywhere. And it doesn't end there. A lot of other devices are getting smart as well. They're becoming computers in their own rights. This morning, Brian showed drones. Well, there is robotics. And these are becoming powerful computers themselves. So where is all this headed? Let's copy Mark Weiser. Mark Weiser said, the most profound technologies are those that disappear. What does it mean? They become embedded or integrated part of your infrastructure. Let me just give you two examples from the last few decades. Technologies that have disappeared or become part of our infrastructure. Number one is electric power. You sort of walk into any room, conference room, your own room in the house, a classroom, you walk into an airport, and you expect that there is a plug on the wall, you plug in, and you get charged. But where is the infrastructure? Where are the devices? Where are the equipments that supply the power? Well, they have disappeared because they've become part of the infrastructure. They've become ubiquitous. Let's take one more example, more contemporary. Wi-Fi. Today we take it for granted that I'll turn on my device and there is Wi-Fi network somewhere. Well, where is the router? I don't even know. It has disappeared. It's become part of the infrastructure. Why do I tell you that? We think that the computers are headed that way. Today the computers are not ubiquitous. They have not disappeared. You still need a device. You need to have a desktop or a laptop or a mobile device or a wearable computer. There is a future that you can envision where computing is going to be ubiquitous and become part of the infrastructure. You will have computing elements, local computing processing, connected to the cloud. Computing is going to be everywhere. Well, if that really happens, how do you interface with it? How do you interact with it? Computing is in your bedroom, embedded somewhere. Are you going to look for a mouse? Are you going to look for a keyboard? That doesn't sound practical. Maybe you want to then talk to computers like you talk to each other. How do we communicate with each other? Well, we talk to each other. We use the visual sensing. I look at your faces. I recognize you. I look at your expressions. We use the gestures. I'm using my hands, and we, along with the language, to communicate with each other. Isn't that how we would communicate with the future computers that become ubiquitous? Yes. If that is so, then we would like to look at the anatomy of human sensing. Because if we are going to make the human computer or human device interactions much like the human-to-human interaction, then let's look at how it's done between the humans. You know, there are 3 stages to this when I'm interacting with you. The first stage is sensing. Sensing, an example is seeing. When the light from the light source gets reflected from your face or the object and they enter my eyes, the light is absorbed at the retina and it gets converted to electrical signal. So my eye then is a sensor and it's sensing. The next stage is recognition or perception. I might then recognize it. I might know the person. That's software. If the first one was hardware, the sensor, the second one is software. The third stage is interaction, where I might say hello or shake your hands. That's the interface. And the first one was hardware, the second one is software, the third one is human factors, is art. And I need to explain to you how we're taking this chain of human sensing to interactions, learning from it, and implementing into our devices. So with Realsense, our goal is very simple. We would like to add this sort of human-like sensing to computing devices. Today, I would like to focus on one aspect of it, which is visual sensing. And I will take 2 minutes to talk about the fundamentals before I show you the technology and the demos. So there are quite a few computer vision researchers here, and so you would see this, you probably teach this in your classes. To us, the 3D world looks like what I'm showing here on the slide. Every point in space, on your face, or on the chair, or on the wall, every point can be described with 2 sets of parameters. One is RGB, or the color. When you specify RGB for a point, you know what color is for that point. Next, X, Y, Z, or the 3-dimensional coordinate. You want to know where that point is. When you have these millions of billions of points, and each of those points, we recognize their color and their 3D location in space, then I can reconstruct the 3D world. So the reason why we human beings, can understand the 3D world and navigate easily and interact with each other is because we have these 3-dimensional visual capabilities where we pretty much see a floating 3D point cloud. To me, the whole world is consisting of infinite number of points that have colors and have a 3D coordinates in the whole world. That's how we see the world. But how about our devices? Well, it turns out that today, most of the devices only have a 2D camera. You have one 2D, maybe multiple 2D cameras. But when you take a picture of the 3D world with a 2D camera, you get a projected 2D image. So in that, you do have the color coordinates for every point, but every point on that flat picture only has X and Y coordinates. You lost the 3-dimensional information. And the math for that is quite easy. It's taught in classes of computer vision. You take the 3D coordinates of the points, multiply by a set of matrices that I'm showing in the bottom, and you can calculate the 2D points on the picture. The problem is, you cannot go from the 2D picture to recreating the 3D world. You can do that for simple cases, maybe human face. But for a genetic rich 3D environment, you cannot recreate the 3D world from the 2D picture. But if you want to implement interactive computing, and you want the computer to understand the 3D world, this is not good enough. There is no way to implement natural visual interaction with 2D cameras. Otherwise, we human beings would have been born with just one eye. There is a good reason why we had to have three-dimensional visual system. So that brings me to the crux of Realsense technology. To a software engineer, Realsense technology is this, what I'm showing in the slide here. The camera, I'm going to show you shortly, captures a pair of images. The color picture, which is what all the cameras capture, but in addition to that, it captures what you call the depth image. That means for every point, every pixel on the color image on the left, the corresponding point on the right image, in the depth image, represents how far in space that point was from the camera. And we do that real time at 60 frames per second. So when you have an imaging device that captures both color and the depth map for every pixel at real time, a software engineer can quickly recreate the three-dimensional world on the fly, real time, like we human beings do in our head, with our eyes and the visual cortex. That's what Realsense technology is. Now let me walk you through the program and the technology in a bit more detail. So as you would imagine, there are various components to bringing this to market. The first one is the hardware, the sensor hardware, the system that includes the Realsense camera. That's the hardware I'm showing on the bottom left. Next, the software. We need to make it easy for the developers to use the technology to build applications. So we have developed Realsense SDK. I'm going to explain this to you in detail. Using the SDK, the developers are building applications. So I'll spend a lot of time today explaining and demonstrating to you some of these applications. Last but not the least, marketing and awareness. If we only build great products, nobody knows about it, then they will not buy it. So I'm going to share with you what you're doing to make people aware of this technology and the products that we're developing with our ecosystem. So when all these elements are combined together, we are able to deliver some amazing, immersive computing experiences. I hope I'm going to show you today. So let's start with the first step, which is the hardware. Well, Brian showed you this morning the cameras. So let me show it one more time. As Brian explained, we have two versions of the cameras. So first let me show you the Realsense 3D camera for close-range interactions. This is the camera that we are integrating in the PCs, laptops, and all-in-one computers. So I don't have a lot of time to explain a lot of detail on how exactly this works, but I'm going to give you a quick overview, and then I'll invite you to download the documents from Intel's website. But in short, this camera has an IR laser and a MEMS projector. Together, they project an invisible pattern of ones and zeros in the space. So we don't see that because it is infrared. But the IR sensor that I'm showing on the camera is taking a picture of that at very high speed. So from these two, the data that we generate, we have built a special purpose processor that I'm showing on the camera here. It's using the data from the IR sensor and calculating the 3D points real time. That processor does only one thing, but it does it very efficiently to calculate 3D. Just like human visual system. The visual cortex in the back of your head is not a general purpose processor. It only does one thing. It only calculates the 3D point from the images captured with your two eyes. And then it sends those data to the general purpose processor up on the head. We have done similar architecture in our computing devices. We want very low power 3D point processing on the camera itself, like the human visual system. And then we want to use Intel's general purpose processor for running applications, running logic, just like we do. So let me move forward and show you the other Realsense camera that Brian just introduced this morning. And that's the Realsense camera for mobile devices. It's longer range, it's smaller device, and it's specifically designed for tablets, phones, drones, robots, and a lot of other Internet of Things. And the way this camera works is this also has an IR laser and a diffuser to project invisible pattern, but we do stereo correlation, triangulation, to calculate depth from what is called binocular disparity, because we have two IR sensors that are taking a picture of the scene. We have not invented these fundamental technologies. This has been out in the academia for many decades. But what we've done at Intel is what we do best. We have miniaturized this technology. We have taken it from these big form factors to tiny devices that can be built into every device. We have lowered the power from tens of watts to a single watt or less. We have reduced the cost orders of magnitude so that this technology can become ubiquitous. So that's the Realsense camera hardware. You can compare it with the RMB on the left. How about the systems? I'm proud to show you a number of laptops and all-in-one PCs that are now already in the market from our partners. The names are showing there. Lenovo, HP, Dell, Asus, and a number of other ones already starting to ship, and a lot many more are on the way. So you can enjoy Realsense experience on your computing device. Yuri, do we have a Lenovo laptop? So Yuri is showing a 15-inch Lenovo laptop with Realsense camera built in that just become available in the market. And there'll be many more you can buy here in China. So let me move forward. That was the hardware. Next, software, because we need to make it easier for the developers to write applications on this. So we have the Realsense SDK. Like Doug Fisher in the morning just briefly mentioned how we are providing these tools to the developer community. So I'm going to do a little deep dive into Realsense SDK. So in the Realsense SDK, we have easy APIs, application programming interface, that the developer can call to get access to the technology inside. And inside the SDK, we have wrapped very sophisticated computer vision libraries, because we want to make it easy for people to build interactive applications on Realsense. First up are the raw data. The developer can get access to the color picture and the depth image on the fly at real time. One level up is a sophisticated hand skeletal tracking library. So the developer doesn't need to use the raw data and determine where the fingertips or the joints are for the user's hand. It comes free with Realsense SDK. We have done a lot of work to make a super high-speed, real-time tracker for human hands. And I'm going to show you a demo of that. Next, a face library. That it's not a 2D face library, but a 3D face library that tracks 78 3D points, X, Y, Z coordinates of special features on your face. And we can use that for avatar, we can use it for video conferencing, we can use it for expression recognition, facial recognition. This morning Brian showed face logging, many more applications. I'm going to show some demos as well. Next, it gets more interesting. We have libraries that allow the developer to extract the human body from the scene and use that for video conferencing. Imagine being in your living room, calling into a video call, and appear to be in your office. So that's possible because the Realsense camera can easily extract you from the environment I'm going to show you a demo of that as well. Augmented reality. Let me just spend a word because I'll show you a demo of that as well. 3D augmented reality. A device that understands the 3D surface so we can bring 3D virtual characters on the physical surfaces, the physical environment, and they will interact as if the border between the virtual world and the real world will be blurred. It's amazing. I'm going to show a demo of that as well. What else do we have? Anybody recognizes this gentleman? You do. This is Brian. So the library, one of the libraries in the SDK will allow you to create a scan of the human body. You can print yourself out in 3D printer, post it on social network, or get your figure in and all that. You can take a 3D model of your furniture because you want to sell it on e-commerce websites. Last but not the least, we also have speech recognition. We want the human-device interaction to be multimodal. It's not just what you see, it's also what you hear. We want to combine this. So we have a library for that as well. And it doesn't end there. It's a call for collaboration. We'd like to work with you just as we do more work internally to Intel. The SDK is extensible. You can plug in your own library in there. It will be extensible in that we will have more libraries coming to enable even more applications that we don't even know today. So Yuri, let's show a couple of demos. I don't have time to show all of them. I'll show some applications. But for the technical view of the SDK itself, we're going to show you the hand skeleton and the face library. For the rest, I'll show you applications. Can you bring up the hand skeleton, Yuri?
Here it is.
So you can see that looks on the two screens, left and right. It's actually the depth map for Yuri. Yuri, can you move closer? So as you can see, as Yuri moves closer, the points get brighter. Can you move back? It gets dimmer. It's actually a pretty fine, granular, 8-bit depth image. Very accurate depth image. So it's hard to see there. Anyway, Yuri, can you hold up your hand? Well, as soon as the camera sees Yuri's hand, you can see it's recognizing his hand skeleton and fitting a physical skeleton through his hand. Can you move it around? Can you show two hands? So you can see the camera can track the 22 joints of the hand, two hands, real time. Imagine playing Angry Birds where the software knows what you're grabbing, what kind of interactions you're doing with your hand. This is going to be game-changing for human-computer interaction. I'm not talking about swiping left or swiping right. Those are easy to do. I'm talking about fine brain interaction, where I might reach out and grab a doorknob and open the doorknob by twisting it and open the door in a gaming environment. Or, like I said, a slingshot game, where I might drag the sling, drag it out of the screen, and let it go. Talking about that level of 3D interactions that we are used to in our physical world. So let's move forward. Yuri, can you show the face library, please?
But of course.
So these are the software views that the software developers can see. So here you see Yuri's scary face.
Hey.
Gone away. Can you bring back the, yes. Those dots are actually XYZ coordinates of 78 feature points on Yuri's face. Let's show.
We're also tracking yaw, pitch, roll.
Yaw, pitch, and roll for his face, besides all the points. We're going to show you applications that use this technology, but for quickly, can you show emotion and expression recognitions? So you can see Yuri is angry, and he's now happy, he's neutral, surprised. So the expression recognition becomes easier with 3D sensing, much easier than when you have only 2D cameras. Okay, so let's move forward. So that was the SDK. I'm going to show you some applications in a second. Applications. Why do we care about all these technologies? Why do we care investing a lot of efforts and money building this hardware sensor and all the software libraries that I showed you? Why do people care? That's because we can actually build new type of applications for traditional client devices like PCs, tablets, phones, but also new type of devices. That's what makes it useful and exciting to people. So I'd like to show you some of these applications. Let me first give thanks to our ISV partners in the software community. We have a lot of very exciting partnership in progress with software companies around the globe. In China, there's a lot of companies we are working with, including Baidu, Tencent, Arcsoft, and many, many more that we are working with. There's a lot of good applications that are coming out of it, and some of them are already bundled with the PCs that are shipping. So when you look at these applications, let's first look at the PCs. And we divide these applications into 3 categories. First is gaming and play. You can imagine gaming where you use the hand skeletal tracking, facial tracking, to make yourself the controller for the content on the screen. Next, capture and share. I showed you 3D scanning. So we have a whole category of very exciting usages, both consumer usage and enterprise usage using that technology. I'm going to show you some. Immersive collaboration, video conferencing, and content creation. That's a 3rd category of application. So let's take a look at gaming and play. Hundreds of games. This is a rich area. Steve Jobs was quoted saying that he was really truly surprised when iPad came to market how many casual touch interactive games followed. He said we could not have imagined that just this casual gaming category would explode. Well, because it happened because of the touch interaction. We totally believe that with natural 3D interaction, you will see another explosion in casual interactive gaming. Just like the touchscreen enabled tens of thousands of interactive games, 3D interaction is going to enable a whole host of exciting applications. I won't have time to show you a lot. I'd like to show you one. I'd like to show you our partnership with DreamWorks Animation in the US. You guys familiar with DreamWorks? Yeah, you are? So the app is Move It. You might have watched the Madagascar movie. I like to move it. So let's bring up the demo and let's see Yuri interact with King Julien of Madagascar. And Yuri has the task here to match every move of King Julien.
I don't have to match that. Sorry, I did just have one.
Okay, so I know that Yuri can go on hours playing this, so we have to stop. It looks easy, but try it with your kids. They'll get stuck to it for hours because there are many levels. It starts easy, and then as you go higher up in levels, it gets more challenging, and it draws you in. You don't want to leave it, especially the kids. That's the customer base for this type of games. They're hooked to the touchscreen games today, and they'll be even more hooked with natural 3D interaction. I wish I had the time to show you many of the other apps, but many of them are already in the market and many coming. I invite you to get Realsense devices and play with them yourself. Let's go to capture and share. And again, there are many demos, many apps. I'd like to show you one. And this is our partnership with 3D Systems. The app is called 3D Me, that allows you to create the 3D scan of your face and put it on a figurine of your choice, animate it, post it on social network, print it out on a 3D printer that will be mailed to your house. Lots of exciting usages. So Yuri, can you bring up the demo, please? Here you can see Yuri's face is being scanned into 3D. He's going to turn his face left.
Right.
He's going to turn it right and then look up. And in a snap of a second, Yuri, can you turn around your face? That's his 3D profile of the face. See how easy it was for 3D sensor to scan his 3D face. And then now he can import it to the character of his choice. So Yuri likes to be a prince, I understand, or you want to be a snowboarder?
Sure.
So that's Yuri. pretending to be a snowboarder. So you can animate it. Okay. You can post it on social network, you can get it printed out in a 3D printer. Can you become a prince? Perhaps.
Yeah. There I am.
So you can see Yuri as a prince.
Thank you.
Okay, and just for fun, how about Yuri? We want to see how you look as a princess.
We don't.
Do you want to see Yuri as a princess?
Come on.
Okay.
There's that. I don't make a pretty princess.
Yuri doesn't like that.
The things they do.
So you can see, there's going to be hundreds of characters you can choose from, and you can get your stuff printed out, animated. So Yuri, can you show a figurine that we printed out before? So that's a 3D figurine printed out on a 3D printer, right? So it's quite easy and quite exciting to kind of application. Okay, let's move forward. I know that Yuri can show this for a very long time. Next, I will show you another one application from the third category, immersive collaboration. We are working with Personify, Tencent, QQChat, Skype, many companies. Let me show you a demo from Personify. Yuri, can you bring up the camera picture, the video call? So that's what you typically see when you dial into Tencent or Skype. It shows your background. See, it's Yuri's background is showing up. But we got 3D sensor, so we should be able to extract Yuri's body from the background. Yuri, can you remove the background?
Of course.
So there you go. So that's Yuri on a virtual background. And he's collaborating, he's presenting this slide somewhere, and he can point to the screen and show the content. Right? You don't know where Yuri is calling from. So there is privacy, and you could be video calling each other, and people will not know what's in your background. So you have privacy, security, and immersiveness. You can put multiple characters on the same screen. Okay, so let's move forward. By the way, in the enterprise users, this is the most exciting application because they clearly see the value of this application rather than the games or 3D printing. So, is there one killer app? No, there are many, and depending on the type of user, different kinds of applications resonate with the user. Let me switch gear and talk about mobile devices. Now you imagine the Realsense camera, the longer range camera, not in the front of the device, but at the back side of the mobile device. Back side of your tablet or a phone, and you're holding it up like that. So for that, we categorize the applications in 4 categories. First, capturing the world, scanning humans, creating a 3D model, scanning objects for e-commerce, scanning the room for virtual decoration, real estate, etc. Second category, photo editing, where you have an additional dimension. You can use the depth information for different processing. Maybe you want to keep the birthday boy who's cutting cake in color, and you want to put the rest of the background people in black and white. You can do that now, because the camera knows the distance for everybody. Very exciting photography application. Gaming, I'm going to show a demo. Here, you can bring virtual characters into the real world. It's truly amazing. Home decoration and shopping, I talked about already. So let's actually see a video that summarizes all this, and it will give you an idea of what all kinds of applications that we're building now, before I show you the demos. Can we show the video, please? gives you an idea of the kinds of applications, because I'm going to be able to show you only a few of them. So let's actually look at the demos. Yuri, can we first show the technical view? Maybe the 3D point cloud of the scene, so people get to see how the camera view looks like for the software engineer perspective. Well, what you see there is the floating 3D point cloud of the scene in front of the depth camera. We also have a color camera. Can you put color on those points?
Can I what?
Are you able to put color on the points? Oh well, of course, you can move it around. So even though he's not moving the tablet, it's a fixed view, but because it's got a 3D point cloud, you're able to move around to get a sense of every point has 3D coordinates. It's not a 2D flat picture. That's the raw view of 3D point cloud. Well, it doesn't look like much. It looks like just a bunch of points. So what can you do with it? Well, it turns out when you are capturing 3D point cloud at real time, you can do wonderful things with it. You can create a 3D scan of objects. So let's actually do that. Yuri, can you do a very quick, I don't have minutes of time, but maybe a quick 3D scan of the table in front of you? Or an object on it?
1 second. Here we go. So by quickly moving the tablet, I'll just...
So what he's doing is real-time stitching together all of the real-time 3D point clouds from different perspectives, and then creating a solid model of the scene in front of him. And now the software is meshing it, processing it, and voila, you got the 3D. Can you move it around to get a view? Is the processing complete? So you can see that's a 3D model. So you can, that's how we have created Brian's 3D model as a person. You can create a 3D model of a furniture, create a 3D model of a scene. That's the basic fundamental technology, and that's what's in the SDK. Let's move forward, and I would like to show you augmented reality, where Yuri is going to bring virtual characters into the real world. So as he's setting up, let me explain to you what you're going to see. So we want the device, the Realsense camera inside the tablet, to understand the 3D surface, so that when we render a 3D character, it can actually sit and stand on the surface as if it's natural. So can you have the sound with it? Can you have him stand on the table, please? Okay. Why is he he's on the clothes? Can he be on the table, the bad guy? Okay, so you can see the robot just jumped down from the clothes and he's working on the table because he understands the surface, right? And he's walking around as if he's a real character, climbing on physical objects on the table.
I don't have to be a robot, by the way.
Could you turn it into a car?
Sure can. Whoa. It's a jump
That's a
car.
bad driving.
Hey,
Okay,
hey,
how about turn it into a helicopter? Okay, that's better. Can you fly it?
I can do better than flying. I can fly away.
So you can see, you don't want to be in a helicopter when Yuri is driving it.
I can fly behind something.
So this, again, shows you the fundamental basic capabilities. You can see he's disappeared behind a physical object. So it's almost like you're flying a real helicopter. Okay, so that's good, thank you. So now imagine yourself, this is just a technical view of a prototype demo. When these tablets are provided to the developers, they can use this technology of scene understanding and build augmented reality apps. Imagine favorite characters like Hello Kitty for kids, interacting with them in the real world, on their bed, on their study table. Imagine racing car in a physical world where you don't need a real car, you can just race it with your mobile device. All kinds of augmented reality, 3D gaming, that's not possible today with 2D cameras. Well, one other thing, how about something useful? Gaming is one, that's good. 3D scanning is okay, you might print it. How about something that's you want to use every day? How about measurement? Brian showed this morning a demo of our collaboration with JD.com, where we have developed an application of automatic box measurement. Well, that's good for enterprise usage in a warehouse where you have to measure the box. But in your house, you may not have to measure the box all the time. But you may have to measure things like, well, how big of a picture frame do I need to buy for my wall? Or, you know, how tall is my kid? How do you do that today? You need a ruler or a measuring tape. But Realsense camera, because it's a 3D sensing device, it can record the true XYZ coordinates of every point. Measurement comes free with the technology. You are able to measure and show something measuring on the table or a real scene.
We can measure a table itself.
You can see he's basically panning his tablet. He selected point A and point B. And as soon as he's done,
84 centimeters.
It's showing 84 centimeters. See, he didn't need a measuring tape. So anything you want to measure, you simply take out your mobile device with Realsense and just measure. That's it. So you talk about an application you might find useful. How often do you find yourself scrambling to find measuring tape? I find it all the time. How about, you know, you are shopping for a furniture, but you don't know whether it's too big for your living room. So what do? Today probably call home and ask them, can you measure this for me? No longer, because you can pull out your phone, a picture you might have taken with Realsense camera, take it up, touch point A, point B, and it will tell you exactly what's the dimension of stuff in your room. So it becomes really useful feature. Yuri, do you have anything else to show?
Well, we can outdo Brian.
Well, this morning Brian showed for the first time a phone with the Realsense camera. And there was already an article I read. The article was very positive, except it wrote, Brian, who takes risk on his stage, did not dare to switch on the phone. So, well, I thought then we need to show it to you. But Brian ran out of time. He had a lot of demos to show. So we'd like to show you, can I show them the screenshot? Right. Everything that you saw running on a tablet or a PC is running on that little phone. Right, you're looking at the depth map on the left and the color camera view on the right, running at real time. So every application that I showed you today, it can be implemented on that little phone. Right, so rest assured that we are going to embed Realsense into all kinds of form factors because we want to transform what these devices can do. Okay, so that's enough on the client devices. How about beyond PCs and mobile? Is it limited only to PCs and tablets and phones? What do you think? Obviously the answer is no. Human-like 3D visual system should be useful for many other things. How about a walking robot that needs to understand the world like we do? If a robot looks like a human, we call it humanoid robots. Don't you want it to see the world like you? So it can navigate and walk around and knows that there is a step there so I shouldn't fall down, right? That's robots. How about drones? Well, drones that fly, don't you want them to understand the environment around it so it doesn't run into things, so it can avoid colliding into things? That's how we and the birds do. When the birds fly, they hardly run into things or fly into things because they have three-dimensional visual system and they can go around things. So, you know, this is something that a drone from Ascending Technologies that we've shown at CES. And what's unique about this drone? What's unique about this is that it has a ring of Realsense cameras on it. You can see on the picture a ring of 6 Realsense cameras on it. So, are you able to show the screenshot of what the drone is looking at right now? Okay, so you can see here the raw view that this drone is able to see. Again, it doesn't look like much, it looks like all fuzzy points. But this is real-time 360-degree panoramic view of the 3D world. Even we don't have that luxury. I only have a 3D view ahead of me, and then I have to turn around to get a 3D view of all around me. With Realsense cameras in a ring, 6 of them, this drone has a real-time view of 3D environment all around it. So what can it do with that? Recently we took this drone and we have unleashed it, released it in a forest on the Santa Cruz Mountains. And we have defined point A and point B on 2 parts of the forest, and we let the drone go from point A to point B, but it had to fly through the forest, all the trees. it had to do it on its own. It had to understand the environment as it is flying fast and then avoid colliding into the trees. Can we run the video to show it? Okay, so you saw how the drone was able to fly at 12 miles an hour. So the dense jungle, they're not colliding into things. It's quite amazing. The first time that the drone has done that. And we are working closely with many exciting Internet of Things companies around the globe, including China. So you'll expect to see a lot of exciting work coming out of this domain where we can provide visual intelligence to devices like this, beyond the PCs and mobile devices. So, last part, like I mentioned before I conclude this talk, how about awareness and marketing? We will build great product, but nobody knows about it, people don't buy it. So we have gotten help from one of our friends. Jim Parsons from Big Bang Theory is the main character. And here you see just one example where Jim Parsons walks into our lab and he has fun with the technology, but he's supposed to keep it secret because, you know, when he saw this was not in the public. Let's see what Jim does. Can you play the video?
What's that? Oh, wow. Hello, humans. Focus on me.
Focus on the guard. Don't tell anyone what you see in here.
Have you seen what's in there?
They have intel. This is where it all changes.
So you can see Jim Parsons is not a good keeper of secrets. Right? He's not supposed to tell this to anybody, but as soon as he's out, he's telling the whole story. Well, the truth is that we want him to tell the story. So you'll see us work with him to help him tell the story for Realsense and many new exciting products that are coming up. We want to help the ecosystem tell the story of their products along with us so that the consumer is aware of it and the products will sell. With that, let me summarize. I hope that I have convinced you of our excitement that the Realsense can add human-like natural sensing to all kinds of computing devices. PCs, tablets, phones, drones, robots, particles, industrial applications. We would like to work with each of you. As the keynote speakers in the morning emphasized, we are here to give a call for collaboration with you. We want to work with you to extend the systems, the hardware. We want you to build innovative systems with us using Realsense technology and Intel processors. We want the software algorithm developers to extend the SDK, build new technology, software technology. We want the application developers to build applications that could help sell these technologies and help you monetize. We want to work with academia to advance the 3D computer vision algorithms. And obviously, we want you to go to intel.com/realsense to get a free download of the SDK. Place order for the developer kit. You know, for those of you that would like an easy developer kit, we have the Realsense modules nicely integrated inside these devices like this with an USB connector, and you become sort of software developer. So work with us. I think the future is going to be bright, it's going to be interactive computing. We can jointly push the interactive computing domain forward. There's a lot more excitement in here. But before we go away, please do fill out the evaluation form for this session. One, I'd like to see what feedback you have for this session, but also you get to participate for a prize, a drawing for a prize. Day one prize today is actually a Realsense tablet, right? So do go fill out the evaluation form. Next, for those of you that are staying today, rest of the day and tomorrow, please join these other sessions. There is going to be a deeper view of Realsense technology presented in Chinese at 3:45 today. Participate in that. Tomorrow, come by interactions with other presenters to talk about Realsense if you have questions. So with that, I have been successful, although this was a rush, in saving 7 minutes or so for questions. So I'd like to see what questions you have. Any kinds of questions are okay. Not everybody at the same time, one by one. Do we have some mics here, right?
Thank you for your presentation. Just one question. So with the Realsense 3D new technologies, I hope maybe more very exciting experiences available. And my question is, what is the minimum technical requirements? I mean, in terms of hardware.
Okay, so I assume that you're referring to the processing hardware, like the application processor. Yes. So for today, the SDK that you can download, the processors for them are either Intel's Cherry Tail processor in the Atom line or Skylake processor on the core product line. Well, you can prototype in other areas, but those are the products that we are working with our device makers to bring to market. And in the future, you'll see us extend that. But for now, those are the two processor lines that we are designing the products for. Any other questions?
Can you imagine discrete Realsense cameras, or will they always be integrated?
Very good question. So for the software developer, the developer is of course discrete, so you can go buy the discrete kit. And the business cases always, we are very dynamic in deciding what makes sense for Intel to go to market with. We have decided today what's in the market are devices with integrated Realsense devices. And the developer kits are discrete and outside. And we are constantly looking at opportunities to extend this. We will decide based on what makes sense for our partners and for Intel.
Because I think after Intel released the Realsense SDK, we just take an order and tried the I think development kit. But we found the resolution of the RGB cameras and the depth cameras is not as good as I would imagine before, because we also tried Kinect and Kinect version 2, also emotions, all these. Because I heard from your colleague from Intel, you are going to release new models of the Realsense, right?
Yes.
But is it possible for you to release some information about the roadmaps of the Realsense in future?
Sure.
Because we are very interested in this one, but when we develop some applications for our some scenarios,
sure,
we still find some limitations. So,
right.
Yeah.
Very good question. Let me take them one by one. First question is on the resolution. So for processing purposes, we have decided that the first product that we have released has VGA resolution depth and 2 megapixel color. Well, now, obviously, better resolution will give you higher number of points, but if we're going to develop interactive applications, the bottleneck was processing, because you have to deal with the data as you are implementing games, or you're implementing facial expression recognition. So the VGA resolution depth was sort of the sweet spot for the mainstream processors. Otherwise, we will be limited to Core i7, and then it will not be in the mainstream. That said, for a mobile device, we understand that for photography, you might probably need to use the external high-resolution camera, like 8 megapixel or 13 megapixel, and we are supporting calibration between the external high-resolution camera image and the depth image from the longer-range Realsense camera, so that you can use the depth from the Realsense camera, and you will have that synced and calibrated with the external high-resolution color picture for photography applications.
That would be good, yeah.
Sure. Number two, let me actually also address your question on Kinect and Realsense. Well, as you know, these two are completely different ball games.
Yeah.
One where you're plugged into the wall and the Kinect consumes 12 watts, right? Costs a couple $100 and a bit more. So we had to, for this product, build something that's 10 times smaller power consumption, magnitudes lower in price, and 100 times smaller. Now, if we decide to build something bigger and have 10 watts of power, we can exceed the performance of anything on the market. But then it will not fit in the phone, right? It's physics. So we have to, at the end of the day, decide. It's like asking, how come the Atom processor in the phone doesn't have the performance of the Core i7 in my desktop computer? It's physics. So I hope that you will work with us in understanding what the device can do given the limitations of the physics, and then build something on it. There are many things that can be done, and then several things that cannot be done, right? We would rather work with you to focus on what can be done. That's what I would like to invite you to work with us on.
So when the next Realsense will be released?
That's a very good question. I did not answer that. So as you know, Intel does not disclose roadmap publicly, but one thing I can tell you for sure, we have a very rich roadmap. Just like you've seen today, this morning, Brian talked about 6th gen core processor and 30, 40 years of Moore's law. Every product we do, when you bring to market, we have a rich roadmap. You will see us continuously introduce much better, improved products in this line as well. And work with us, work with what we have now, and then you will be able to participate with us in better products, more features, and the feature will be even better. Yes?
Thank you for your presentation. So I have one question. So in your PowerPoint, you mentioned 2 types of Realsense. One needs one read projector and one receiver, and another type needs 2 receivers. So I don't know the reason. So that means the first type, the technology of first type, there is some limitation about the long-range depth detection.
Right, very good question. Yes, like every technology has plus and minus. So for the first one I showed, it's a close-range camera. It's based on a technology called ported light, or in academia it's also called structured light. So you send out some well-defined structures of IRs, and then you're using a single camera that's displaced from the emitter. And the limitations are several. One is close range, right? You don't have range beyond what the camera can see, about a meter or so. The second, you cannot have multiple cameras look at the same point or scene. Then they'll confuse each other, right? So those are the 2 limitations of it. But the strength is that you get really highly precise depth map when you're working on a single camera, close range. Whereas on the second device, it was using stereo 3D vision technology, but much better 3D data than what you typically see, where there are many products out there with just 2 cameras, right? But those depth map quality are really bad. So what we've done is an IR emitter to create specs in space that gives us very high quality of depth in an area where there may not be feature points. Strength of this are that you get a longer range, and the devices can work with each other. We can have 2 tablets looking at the same scene. So depending on what application we have, we can guide you through what you need to choose, right? They have been optimized for 2 different usages. So we are out of time. Okay. So thank you very much, and I look forward to working with each of you, those of you that are interested in exploring Realsense and pushing the limits of interactive computing with us. Thank you.